We're going to be discussing simplifying radicals. Now, the thing is, sometimes it is very useful to have a rounded answer, a type of answer that a calculator can give you. But the issue is whenever we round, we actually end up with a little bit of error. So it is preferable to sometimes have an answer that is exact. So, what do we mean by that? Well, if we were to have something like the square root of 32. So, the square root of 32. Now, here's the thing. If we were to use a calculator and figure this out, we would get that this is approximately 5.66. Now, this is, as I said, sometimes a good thing, but sometimes it has its issues. So, what we can do instead of getting this type of answer is we can simplify it down. And the way we do that is first we factor the number. So, 32 we can factor into 16 and 2. Now, let's pretend for a second that we don't know what the square root of 16 is. And I say that because once we have it written like this, we can rewrite the problem as square root of 16 times the square root of 2. And we know that the square root of 16 is 4. But let's pretend that we don't know that right now. So what we're going to do is we're going to factor this out into 2 and 8. We're going to factor this 8 out into 2 and 4. And let's pretend again like we don't know that 4 is a perfect square. 2 and 2. So what we could do is we could rewrite this statement as the square root of 1, 2, 3, 4, 5, 2 to the 5th. Okay, that, however, does not necessarily help us out all that much. But what does help us out is this. If we look here, I have a pair of 2's. And what that pair of 2's means is I can write 2 outside of the radical. So I look for another pair. There's another pair of 2's. I can write that 2 outside of the radical. And then that leaves me with 1, 2. That has nothing with it, so square root of 2. And then this simplifies down to 4 times the square root of 2. So we factor the numbers, and then we group the numbers. According to index. Okay, so what do we mean by index? Well, a radical expression is essentially this. We're taking the nth root of a. Now, what this actually does, though, is it gives us an index. And that index, I apologize if you hear my cat in the background, that index, it tells us the size of our groups. So this tells us how big of a group we need to have. Okay, let's continue with square root of 32. Or not square root of 32, let's change it, but let's keep 32. Let's say we want to know what the third root, or the cubed root of 32 is. Okay, again, we're going to factor this down. I'm going to do 2 and 16, 2 and 8. Now, if you were good with cubed roots, you could stop here, because the cubed root of 8 is 2. But pretending we don't know that, that's 2 and 4, and that's 2 and 2. So, I now need to look for groups of 3, because my index is 3. There is a group of 3. Okay, so what that tells me is I can write a 2 outside of my radical. Now, I don't have another group of 3. And since I don't have another group of 3, everything else has to stay inside the radical. And this gives us 2 times the cubed root of 4. This method works for any number, if we want to simplify the radical down. And eventually, after you do these a lot, you get used to them and you start being able to stop. And you start recognizing, oh, this is a cubed root, so this is what I'm looking for, or stuff of that nature. Okay. This is not the only method of doing this. This is just the method that I wanted to discuss here. So, we have our simplifying radicals, has all this wonderful information that goes along with it, and the long and the short of it is just factor the number down and then group your factors according to the index. Okay, that will do it for this video, and I will see you in the next one.